Hi everyone, we're going to graph these two piecewise defined functions. They're very similar, except the upper portion and lower portion kind of got changed. We're going to test for continuity for both of them as well at x equals 0, because at x equals 0, this is where the change is occurring on the left side and the right side of the graph. So let's do the first one. So here's your definition of continuity, and it must meet three conditions. The first condition is that f of c exists, and that means our c is 0. Like I said before, 0 is where it's changing. It's linear, and then at 0 it turns to a point. So we're going to see if it's continuous. So the first thing, does f of c exist? So does f of 0 exist? So we have to plug it in the lower portion, and f of 0 equals 1. Right there, that's your y. So that does exist. So now we have to test the limit to see if it exists. And we're going to look at the left hand and right hand side limits. So we're going to look at the limit as x approaches 0 from the left of our graph, and the limit as x approaches 0 from the right of our graph. What's going on? Is it continuous, or do we have any jumps? So basically, here's your 0. It's talking about what's going on the left as the graph approaches 0 from the left. And if you notice, all these numbers in here are less than 0. And then we want to look at what's going on as the graph approaches 0 from the right. If you notice, all of these numbers here are greater than 0. So that's what we're going to look at when we do the limits. So for this first one, we're looking at where x is less than 0. So plug in the 0 into that x, and you get 2 times 0 plus 1, and that equals 1. Now we're going to look at what's going on to the right of 0, and that's where we have here, and this is also going to equal 1. So what we have is 1 equals 1, and so since the left-hand side looks like it equals the right-hand side, the limit does exist. So that's a check. Now, for the condition 3, we have to use the limit as x approaches c of f of x. That should, and it was going to be 0 now, that should equal f of 0. So we already know that this equals 1, and we know that this equals 1. They both equal each other, so condition 3 is also met. That means this function is continuous. So when we graph it, we shouldn't have to lift our pen. So let's test the continuity of this one first. So again, we're checking f of 0. So f of 0 is going to equal, you plug in 0 here, you get 1. And then we're going to test the limit as x approaches 0 from the left. And again, that would be, this one would be the left and this would be the right. And that should equal the limit as x approaches 0 from the right. And from the left, if you just do that, that's going to equal 1. And from the right, this is this one, which we did here, that also equals 1. So they match, so condition 1, 2 work out. And also it's very clear that our limit as x approaches 0 of f of x equals f of 0, because 1 equals 1. So this one's also continuous. So let's graph it. So when we graph it, we're going to do start with 0. And at 0, you plug in 0 into this, you get 2 times 0 plus 1. That equals 1, but it can't equal the 1, so it's open. All right? And then we're going to graph to the left. So let's try negative 1. So you go 2 times negative 1 plus 1. That's negative 2 plus 1 is negative 1. So that's here, where we plug in negative 1, yeah. And since it's linear, that means I can just keep going down. The slope is 2. So I'm trying to make the slope 2. So it goes on like that. Now for this portion, that means at 0, plug in 0, it can equal 0, so that goes to 1, so that closes in that. Every other number after here always goes to 1. This is like saying y equals 0x plus 1. Alright, so that means whatever you put in for your x, if I put in, this is 4, if you plug in 4 times 0 plus 1, that still gives you 1. So there's the graph right there. Alright, and it's continuous because when you graph the whole piece together, you don't have to lift your pen or your pencil. Now this one, let's do the same thing. For x is 0, this is our c, remember? It goes to 1, but it can't equal it. And then all numbers less than 0, it's always going to be 1. So it goes that way. And then for greater than 0, you plug in 0 into here, and that's going to give you 1. So closed interval overrides open. Then plug in 1. At 1, that maps to 3. And it's going to keep going up by 2 because the slope is 2. And so there it is. Going up by 2, and so forth. So again, this graph is continuous because you can draw the graph without lifting your pen up. There's no jumps or point discontinuities. And that's it. Thank you. Have a nice day. Bye-bye.